In this video, I'm going to see how far I can ride on a cardboard bike. Yes, with cardboard wheels. In the last few videos, I've built quite a few vehicle projects. Most of these were made from steel, plywood and 3D printing, as well as the electronics. I generally recycle most of the parts from my old projects. The motors and electronics can be reused, steel cut up and welded back together again to make something else, and 3D printed parts get mashed up by Handy Dan's 3D prints and turned into flower pots. But what if I could make a project that could be even more easily recycled? I previously made a cardboard skateboard which was pretty tough. It was made of 5 cardboard tubes glued together and attached to some 3D printed ends which I had normal skateboard wheels attached to. But could I make the wheels of a vehicle out of cardboard too? So I bought a bunch of cardboard, and that comes in a big bale. There are 50 pieces here of single corrugated cardboard, and of course none of them come fixed together or anything like that, they're just wrapped up in plastic. If I hold them together though, then it looks like it can support my weight okay. If I don't hold them together they skew and I fall over, but it looks strong enough that all of those bits of cardboard together will be able to make a wheel that will support my weight. So the plan is to cut out 50 circles of cardboard, mount them on a cardboard tube that should be strong enough for the axle, and glue them all together to make a wheel. On the bottom of the wheel, of course, there is a curve and a smaller piece that touches the ground where all the force is going to be, so we'll have to see how that works out when the edge isn't straight like it was in the bale. So I've made a template to cut out all of the circles, which I'm going to do by hand. It would be great if I had a laser cutter that would accurately and precisely and quickly cut them, but I don't, so I'm using a knife to make all of the cardboard discs. And of course we need 2 wheels, so we actually need 100 of these. I designed a jig so that we can get the wheel built straight, and also so that we can get the cardboard discs in the middle of the axle, which is a cardboard tube with a bit of cardboard tube sticking out either side so we can mount it. So I CNC'd out some MDF, and basically what I've made is a platform, and that allows part of the cardboard tube to stick into the platform. So we start building the wheel halfway up, we stack up 50 cardboard discs, and then that allows us to have a bit of cardboard sticking out the other side as well so we can mount the wheel. So first of all I stuck down some plastic sheet so that I wouldn't glue the cardboard straight onto the MDF, put down the first cardboard disc, and then I sealed that on with hot glue, and that will stop the other glue that I'm using basically running down the tube and gluing the whole thing to the base. So now it's time to get gluing, and I'm just using PVA here, which is just white glue, to glue all of those discs basically in a massive stack to make that wheel. I cut out another disc, and that's got a slightly bigger hole in the middle, and that'll allow me to push down all over fairly uniformly to glue the discs together. And eventually I'll put weight on the top of that when all of the discs are glued down so it can hold the whole thing in place. So yeah, we just keep going, adding more discs, adding more glue, and pushing them down and sticking them all together. And I'm just using whatever PVA glue I could find in a large container. So we keep going, you can see the thickness built up here. We need to glue down 50 of these for each wheel. So here's my first wheel, and that's 50 discs glued together. That gives us a thickness of roughly 130mm for the entire wheel, with the axle sticking out either side. So now I can put my pusher piece of wood on and put on some heavy weights so we can let that glue up, and hopefully it'll all come out solid. So the glue's all dry, and yes, I've made 2 of them because we need 2 wheels for the bike. So yeah, it seems pretty tough, pretty sure it's going to be okay. Obviously we've got this square edge, so it might be a bit weird to ride. I think what's going to probably happen is the edges are going to get compacted down and it'll end up slightly curved. I am considering sealing the surface with something, but we'll probably wear it in a bit first and then think about that later. Before I carry on with the project, I thought I should just do a quick test and check it'll actually take my weight without the cardboard wheels immediately folding and buckling under me. But so far that's looking pretty good. I am on soft carpet, but those wheels are looking absolutely intact, and the surface is pretty hard actually with all of that glue on there. The rest of the construction for the vehicle is going to be the same tubes as the axles, which are pretty strong tubes, and these are roughly 110mm in diameter with about a 5 or 6mm wall thickness. So this is roughly what it's going to look like. I am going to use 3D printed junctions to join the tubes together because it's already got cardboard wheels and most of it's made of cardboard, which is sketchy enough, and I can't think of an easy way to actually join those tubes together. These tubes are quite a big diameter, so the parts are quite a big diameter to fit over them as well. So I've printed them all with the 1.2mm nozzle, so they're all pretty tough. There's only 2 perimeters and about 10% infill. So just a quick ad from my 3D printer sponsor. Thanks to Lolsbot for supporting my channel with 3D printers. There is support material in these which breaks out just the same, and that should leave us with some really good looking parts. And thanks to 3D Fuel for the filament for this project and lots of other projects, so check out my channel for more 3D printing projects and check out 3dfuel.com. The first 3D printed part we're going to look at is this plastic shim which a bearing fits on very neatly. Thanks to Simply Bearings for the bearings for this project, check out simplybearings.co.uk. These are some pretty substantial bearings, and these are for the wheels because I didn't want to run cardboard on cardboard, and of course that shim is just to make it the right space for that cardboard tube because I couldn't find any bearings exactly the right size. I'm sticking all the plastic parts to the cardboard with some contact adhesive I found. On the back wheel, we've got 2 of those, and one of them actually has a pulley on, so we can drive the whole thing along. The other half for that bearing is also another substantial print printed with the big nozzle, but I made a part with a finer nozzle to actually fit the bearing in accurately, so I don't have to reprint the big part if it doesn't fit properly. So of course that will fit onto the other shim that I already made, that's fitted to the wheel, so now we get a really substantial wheel bearing, and in fact these joints and the wheel bearings are probably overkill. They're much more substantial of course than the cardboard wheel. My contact adhesive appears to have gone off a bit, so it's quite stringy. It should be more runny than that, but it probably works perfectly well, and it means I can get loads on the spreader to get it in the hole there. So basically I've already primed the cardboard tubes with PVA, which is why they look a bit shiny now, and that helped me with the cardboard skateboard. So obviously just sticking that in, spreading the glue around as much as I can, and then letting it go off, and we'll see how strong it is. But hopefully that should be pretty good. Some of these parts I've made in 2 halves, mainly because they didn't fit on the print bed, but also it means that I can build the bike in 2 halves and then fit them together, and I've left bolt holes as well as gluing them onto a central piece in the middle when I put the 2 halves of the bike together. So yeah, the bike's pretty much designed to be split in 2, and that means I can easily assemble the forks for each wheel in 2 halves and then put the 2 halves together. And you'll notice there's at least 2 tubes for all of this structure, the 2 pieces in the middle and the 2 for each of the forks, so that should make it nice and strong. The closest thing I've got to steering bearings is this top hat piece that fits in, so I'm running plastic on plastic instead of plastic or cardboard on cardboard. I was going to try metal wheel bearings, but I thought this would probably do. I thought I'd try some hot glue on some of these to see what happens, so I've got a very short piece here with 2 ends on which have notches in, and that piece is basically a pillar between my 2 crossbars that holds the whole thing together. Most of the load is from the top onto the bottom, and that's because I'll be sitting on the top, and I've got my 2 steering pieces which basically make up the steering column with those 2 hi-hats. So basically I need to push the 2 down, and then both of those steering linkages will apply force to the front forks. So I did half at a time and then went and hot glued it. We'll see how well this sticks, but basically that's the best way to kind of get this aligned without having to clamp it in place. So now we've got the steering column, and I put a cap on the top as well to stop it falling out the bottom, so that looks pretty good. Yeah, the hot glue just broke off the edges, it didn't stick to the 3D print very well, so I put some zip ties on, but I've got a cosmetic plan for covering that later. Most of my other joints are really good, but the cardboard is basically very tight in that hole, so the glues work really well. The next part, it's really much more critical. The tube doesn't slide because there's no end cap on these. So I'm using that expanding Gorilla Glue glue, which expands out and fills all the gaps to make sure it's stuck properly. So my front forks are all glued up, which are of course a symmetrical pair which fit together and glue and bolt around that rotary piece I've already made for the steering column. I've also made the back forks as well with those funny angle pieces. And you can see that Gorilla Glue has foamed out and filled all of the gaps. But before we carry on with that, it's time for a quick ad from the video's sponsor, which is Xometry. I make most of the parts on my own projects, but sometimes there might be a part that I don't have the tools or equipment to make. Xometry solves that issue, and it's accessible for anyone from large corporations to the hobbyist. Anyone with a CAD file can upload their design to Xometry's instant quoting engine and within seconds get instant pricing, lead times on production and DFM feedback. Xometry's quoting engine is quick and simple to use. Xometry offers an exceptional range of manufacturing options with over a dozen manufacturing processes, including various types of 3D printing and CNC machining, sheet cutting, injection moulding, die casting and many more. Xometry also offers thousands of materials and finishing options. You can select from a number of economic domestic and global shipping options to impact lead times. Thanks to Xometry's immense network of over 5,000 global manufacturing partners, ordering with Xometry is more affordable than most other options. Plus, Xometry offers a number of smart and easy financing options so you can get the parts you need now and pay later. So no matter how big or small your custom manufacturing project may be, you can start your manufacturing project with Xometry. Visit xometry.com/Bruton to get your design quoted, produced, and in your hands in no time. So I've glued and bolted those front forks onto that rotary steering column that I'd already made, so that seems to be working alright, and I've also fitted some handlebars so that I can turn the wheel, and that's looking okay. At the moment, I think these 3D prints are pretty excessive. I probably could have got away with making them slimmer, and I think these cardboard tubes are probably excessive as well. The wheel still feels a bit soft in comparison to everything else being corrugated cardboard, but at least we know the rest of the structure probably isn't going to fail. Right, the back's on, and it looks like a bike. So the key thing is here that these 4 joints are all glued up and they're rigid, and that holds these 2 tubes at the right spacing, so the force from the top is pushed through here and pushed down to the bottom and everything's loaded properly. The front is slightly different though, which is why we've got this piece in here, this upright, so when I push down on here it takes the load onto the lower tube as well, and that's because these pieces aren't attached rigidly to the front, so the steering works. And that means when I sit on this crossbar, we're actually putting the load onto both of these, which are resting on both of the pieces below there, so the force is conveyed equally onto that steering column. Yep, it seems to be definitely strong enough to take my weight as well, so that's pretty good, and it's pretty easy to move the steering wheel, so we're all good there. Time to sort out the drive mechanism. So I've attached a piece which has the motor mounted, and that's 3D printed and glued onto the tubes, and that has a slider in with a piece of studding that I can tension to pull that belt tight, so we can always adjust the belt tension. Yep, so that's looking pretty good, and obviously we've got a 3D printed pulley on there, and that's because my metal one didn't arrive in time. So this is a brushless drone motor, which is a Turning G Aero Drive 6374 149 kV, and I've used these in loads of projects. To drive the motor, I've got a VESC or VESC controller, which is for skateboards, and I've got a 6S LiPo, which is a high drain one, and it's 4 amp hour. Both of those fit in the tubes at the back conveniently, and now I can run that wheel, which seems to not be running too bad. It's pretty much on centre for something I made out of a bunch of cardboard, so obviously that jig helped quite a lot. And to control it, I've got an e-bike kind of thumbstick thing that's supposed to go around the handlebars, but it can't because the handlebars are too fat. So we seem to have enough torque at least to push me along, and we're using magnetic braking or regen braking, but that's looking pretty good. So I'm pretty happy with how that's turned out so far, but we need to make sure people watch the video so it's not just a waste of time. YouTube algorithm really likes it when people click on the video. If that click-through percentage is really high, then it shows it to more people who hopefully click on it. So I'm saying in the YouTube title that it's a cardboard bike, but the 3D prints have turned out a bit more overwhelming than I expected them to be. So basically I'm going to cover some of the plastic with brown paper tape so it looks more like a cardboard bike, and hopefully people watch it. We have got cardboard wheels though, but yeah, I know it's cheating, but that's society's crime, not mine. Well, it looks a bit like something Fred Flintstone would ride on, but it also looks like a cardboard bike, so hopefully that makes it really popular. I put a foam pad on here so I'm not sitting on that 3D print, so it's nice and comfortable. Well, I thought the hot, dry weather would be a good time to do this project, so it's dry outside. But as soon as I finished it, I need to test it. It's raining and there's going to be thunderstorms forever, pretty much. So I need to do something so I can still test it. I'll take my chances with the weather, but I probably need to seal the wheels so they don't go soggy if I run for a puddle. So I'm using some liquid latex, which is the nearest thing I could get to cardboard basically, because it comes out of a tree. There are obviously plenty of other types of sealant, but they're generally solvent based, and this is basically water and rubber, so when the water evaporates it just leaves the rubber, which is about 60%, and it dries a nice cardboardy brown as well. I left that overnight and the latex has darkened up a bit, as you can see. The sides of this are still a bit squashy, but the latex has still got a fair way to go. It will darken up and go a bit more solid, so hopefully that'll be okay. Well, here's the first casualty. I managed to snap the handlebars. There's actually two tubes, one inside the other, but I didn't glue them together with PVA, just tacked them together with a bit of hot glue. So I seem to have put too much weight on it and snapped them, but the rest of it's holding up so far. So far so good. It actually goes about twice as fast as this, but the camera person following me is on rollerblades and the ground is covered in sticks, so basically I'm not going too fast because otherwise I'll outrun them really easily. So probably a good time to have a look at those wheels and see how they're holding up. It looks like they're pretty good actually. You can see around the edge that it's kind of compacted and there's a bit of a funny rim where I've been leaning left and right, but apart from that they're looking pretty good. Most of my weight is over the back wheel and that one's looking okay as well, probably slightly worse, but there's not much in it. Well, it actually is much stronger than I thought it was, so there's quite a lot of this footage, but I wanted to include it so you can see how far it actually went, although I have cut some of it out because otherwise the video is going to be an hour long, and the answer's several miles before something fails. It does fail in the end though, so skip if you want to see what breaks, but it isn't the wheels and it isn't the cardboard structure. So much like the cardboard skateboard, it's actually much stronger than I thought, and this is still in one piece, and in fact so is the bike. So, I think that the structure's pretty good though. If you needed to make some cheap wheels, then this isn't a bad way to do it. Perhaps hard coating them with something and painting some rubber on the outside, perhaps Plasti-Dip or another solvent-based sealer would be quite good. If you had to make a robot or something like that on a budget with big wheels, it would work quite well. So I think there's lots of things we can make with this structure with thick tubes, or even thin tubes like the skateboard, which are of course are much thinner, and I actually put tubes inside tubes here to make much stronger tubes, so there's 3 layers of tube, and 7 tubes and not 5 as I said at the beginning. So you could make all sorts of stuff, and I'd really like to make a supercar or something like that. Obviously with 4 wheels the load would be spread much better, and all we need is 2 of those steering mechanisms with a steering linkage, and I'm pretty sure all of that could be made out of cardboard tubes and the 3D prints. So I'm going to publish all the CAD and code for this as usual. If you'd like to support me through Patreon or YouTube channel membership, then patrons and YouTube channel members can get access to all the videos early, including sneak peeks and pictures of what's coming up, so you can be part of that discussion. So yeah, keep going, skip forward if you want to see what happens in the end. Right, so this is towards the end of the video because this is where something finally fails. But it isn't cardboard. No, it was the plastic pulley on the motor which has finally given up. It looks like it might have been slipping for a bit, or the motor got warm and the PLA is melted and the pulley is broken and on the ground. It's pretty carved up. Apologies for the focus here with this camera. But I'm pretty surprised it lasted that long, to be honest. Right, the wheels look okay though, so this has done several miles on this now. Some of the footage has been cut down. Obviously the video's too long as it is. But yeah, those wheels are looking okay. They're slightly compacted, but actually I think there's probably a limit to that. And they're alright. Again, most of my weight was over the back wheel, so that one's slightly worse. But I'm pretty surprised how these have held up, and the whole structure's okay apart from that.